Good morning, John. I hope you're well. I understand you've got some questions about the flywheel and its measurements and all that, and more than happy to address them. There's a reason I no longer help people on the internet, and this is one of them. You get other people coming along and basically telling you that you're wrong. So anyway, let's get into it. So first of all, there was a good reason I didn't really go into some real detail. First of all, I didn't know that you're an engineer and appreciated this. I kind of have to tailor my videos for my clients for all levels of understanding and engagement. And to be honest with you, the vast majority of my clients don't know or don't care about tapers on flywheels at all. For them, it's enough to know that I've measured it and I say that it's out of spec. And then we just move on from there. However, we're not there at the moment, so let's just get into it. So here are the specs here. So there's no need to do any trigonometry at all. It's actually drawn and written on the diagram what the actual change in height, i.e. the taper between the inside and the outside of the actual flywheel surface or working surface here is, and it's 0.07 plus or minus 0.03, so we're 0.04 to 0.1. So yeah, that's the spec. This is a brand new flywheel on our surface plate. It's not an OEM flywheel. This is made by Hill Engineering. I'm actually very good friends with Paul Hill, and we do a lot of development work together. And this has been done in conjunction with me, and it is made to factory specs. We've not only used the drawings, but bought several flywheels from different batches to actually measure them and make sure that we actually replicate, or Paul replicates, what the OEM spec is. And we're actually doing the same with the 430 flywheels. And actually hopefully going to be releasing a 430 flywheel very, very soon for Hill. You'll notice I've changed dial gauges. This is my Mitutoyo gauge. It's got an in-date calibration certificate. It's the one that I use for dialing the engines up. This thing here is just for a quick and rough and ready measurement. We also have because of the length of the stem here, it actually introduces a bit of an error, because as you drag the flywheel underneath, it actually bends this here and actually changes the distance slightly. So shorten the pointer down. We're set to 0, and just 0. Make sure that is zeroed, which it is. And then we can just move it across to the outer edge. So we are 0.08 and a fraction and a smidgen. So that's well within the spec here. Now, now some smart aleck will go, well, you use different gauges for here and here. So I've actually redone this one on I'm using this gauge here, and I'll send it as a separate video because it's a bit of a faff to switch them around. This is actually worse measured on the calibrated gauge using this method than it is using this one here. Significantly worse, 0.4 dead. So for all intents and purposes, about 0.5 mil. Final thing to talk about is there's the expectation that the flywheel would wear the other way round. Well, yeah, if it was wearing on the outside edge, if it was actually wearing, then yes, it would. It would be sort of lower down on the outer bit here. But it's not wearing. Well, it is wearing, but what it's doing is dishing. So as it gets hot and overheats, it actually curls up at the outside edge. So the outside edge gets higher. When it again gets misshapen, I suppose is probably the best way to describe it. And then that exacerbates the problem, because then you're only touching on with the friction material on the outside, which then generates more heat on the outside edge, which makes it flip up even more. So it's kind of, as soon as you're in that situation, it just gets worse and worse. So that's where we are. Give me a call. Let me know if you want this back in. If you want it back in, it's no drama for me at all. I'm going to start your build up later this morning, so I'm more than happy to put that back in if that's what you want. I can hold that in stock. It's no drama for me. So yeah, let me know. Speak soon. Cheers.